So as a point of order for business of the chapter, I'm not aware of any change in our requirement on being virtual meetings. The last that had been communicated that we'll maintain virtual meetings all through the remainder of the year, and that is from nationals. So unfortunately, we won't be able to do our typical meeting in November where we try to get all of the section together for a dinner. So we will postpone that, and hopefully we'll be able to do that in the spring. Other than that, I don't believe there's any other points of order for business purposes of the section. So without further ado, I welcome Kiran Murthy this evening to present on data integrity. So Kiran, if you wouldn't mind unmuting and give your introduction, and we'll get into your presentation.
Sure. Thanks. Thanks, Jared. Actually, I forgot to pull up the intro. All right. So, thanks everyone. My name is Kiran Murthy. I'm currently a senior quality systems engineer with Integra Lifesciences. Jared and I have been working together for the past 3 years prior to our acquisition by Integra Lifesciences, just at different facilities. So before ACell, I was working at various other medical device companies throughout the industry, namely Boston Scientific, Medtronic, and Sanmina the Sanmina Corporation. And before that, I had gotten my master's in biomedical engineering from Drexel University. Right now, I have my my CQE from ASQ, which I got back in 2017, and then my PMP from PMI, which I got back in 2019. So tonight I will be talking about data integrity and Industry 4.0, which a lot of these are buzzwords that we hear being thrown around nowadays as we talk about advancements in manufacturing and how we are keeping up with new technology. Can everyone see my screen? Okay, perfect. All right, let me begin. Okay, so quick disclaimer. So everything that's in this presentation is I prepared by myself or have sourced from other public websites online or from ASQ. And everything here is my own views and don't reflect the views of ACell or Integra or anyone else. So tonight I'm going to be giving an overview of data integrity and Industry 4.0 and Quality 4.0 and how they're all related. And then from there, I'll go into a little bit more detail about Industry 4.0, a little bit more on data integrity, and then how we go through about implementing Quality 4.0 and data integrity controls before ending tonight. So quick overview. So with technology advancing as the way it is, we as quality professionals have to be able to keep up with demands, with manufacturing demands or services demands by services without compromising the product or service quality itself. So the way we end up doing that either is by hiring more and more quality professionals, or we end up automating a lot of the decision making that we end up doing. The automation part is the direction that what we'll be focusing on tonight. So in order to keep up with those internal and external demands, quality professionals must also learn about and also implement additional monitoring and control methods to acquire data and make appropriate decisions based off of that data. But then with the implementation of those additional monitoring controls and those control methods, we have to be able to show that the data that we've collected is trustworthy in order to trust the decisions that are being made in real time, so that we don't, so that adverse events don't occur as a result of our decisions being made faster and faster. So first I'm going to talk about Industry 4.0. So what do we actually mean by Industry 4.0? So this is one of the first buzzwords that you guys will be hearing this evening. So what we mean by that is about the phase of technology that we're essentially witnessing right now. So what it means is that it's a reference. The 4.0 is a reference to the fourth industrial revolution that is occurring as we speak. A brief history on that. The first industrial revolution that we all know about. This is when steam power first became very prevalent, and it allowed for faster mechanical production. The second industrial revolution was occurred when electricity was added to the manufacturing processes, which allowed for mass production and assembly lines to occur and allowed us to start some level of automation there with electronic controls. In the mid 1900s, with the advancements
Hey, Kiran.
Oh, yeah?
I apologize, but are you indexing your slides at all?
I forgot to put those on there. I can.
Okay, no, I just wanted to make sure in terms of the presentation. So.
Okay, yeah, I can add them after
Yep.
after this presentation.
No, you're good. I just wanted to make sure if you were sharing a different screen or not. So I appreciate it. Sorry.
Okay, all right, no worries. So the third industrial revolution that had occurred was in the mid 1900s with the advancements of transistors, which allowed more basic robotics and electronics to allow for automation and networked productions. And then where we're going through today is what we're referring to as Industry 4.0 is the Internet of Things, better networking between machines themselves, and cyber physical systems. So from a quality standpoint, we also see advancements of how we are actually able to go through and assure the quality of the products or the services that were produced through this as technology was advancing. So what was referred to as quality 1.0 was self-inspection that was performed by individual shops that were around at the time. At that time, there was not many standards around. It was just up to the shop to make sure that they were meeting the requirements of their customers. Quality 2.0, that's where things became more standardized, where we have the issuance of military standards and better inspection and controls around how we actually go through and make sure that we're conforming to requirements as we begin mass producing things. Quality 3.0, what we see there is that we start seeing software for QMS, for quality management, and also better improvements or better continuous improvement, better planning of from a quality management side. And what we will be seeing tonight is from a quality 4.0 standpoint, is how we take that data and essentially how we're going to be able to make data or make real-time decisions based on data collected in real time using continuously collected data or real-time data or the Internet of Things. So so like the last line is at the bottom. It's like what we are referring to tonight, or what we'll be talking more about tonight with regards to putting in these controls and allowing for advancements to keep up with better and more advanced manufacturing practices. So why do we care about this? So what we see as we start implementing quality 4.0 practices is that it allows us to move from just understanding what is happening, or move on from just the basic of what is happening in our manufacturing processes up to a point where we can predict what is actually about to happen or what is going to happen. So as we collect data, as we understand more of our process and understand how various inputs change, or how changes in our process can lead to different things with our product or with our service, collecting that data allows us to create better trends and better models for allowing us to make better decisions. And that's where we go from just having reports or monthly or quarterly reporting schedules to more, where we go from what's happening to what has happened, where we're seeing a snapshot of what's happened in that previous quarter. So that's the second line that's here of what has happened. As we go through our investigations,
Hey, Kieran, I apologize. Is anybody else seeing the slides index, or is everyone still on the title slide?
Still on the title slide.
Oh,
Yeah, sorry, that's what I was trying to get at earlier there, Kieran.
oh, I'm sorry about that. Um, okay, can you see a slide with that's with the title Industry 4.0 and Quality 4.0?
Yes, we can see that now. Thank you very much.
Okay, yeah, sorry about that. So, with the advancement, um, so what with Quality 4.0, with the practices that come along with the advancements of technology, we're going from having a snapshot of how things are going and occurring in the past, and taking that from what is happening or what has happened, and we're moving towards using that data to try and predict what is going to happen. The way you and what we are trying to do with that is collect as much data as possible in order to make sure our predictive models are able to be as accurate as possible. So as things change within the manufacturing process, like how lots are varying over time, or where they're coming from different sources or different suppliers, how materials are changing over time. Like once we have that information, we can start using that to feed our models or feed into our models to get better information about how that's going to impact our products, and it can allow us to plan for that much better. So the main prerequisite for this is a ton of data. What we want to understand is how these different minor changes, which we may not consider having a large effect size on our product, those minor changes could still have an impact on other factors within the manufacturing process. So understanding how the interaction between the different inputs or your different variables would also allow us to build better models of how it's going to move on and allow us to make better decisions moving forward. It can also help us with reducing downtime in the future too, because if we know that, say for example, raw material that we're using has we see seasonal changes in that, and that's something that does actually have some kind of impact that our customers don't want. We can actually take that into account and try and source that from different suppliers where we're not seeing that seasonal impact, or see if we can understand what is causing that seasonal impact. And based off of that, like since that's something that's cyclic, we can feed that into our models and try and move forward with how we can try and improve our manufacturing process and ultimately achieve our business goals. So the idea or the end goal in this is still optimization and moving towards making sure that we are producing good quality product without sacrificing time or extra essentially make sure we're focusing as much as we can on cost of quality. So with Quality 4.0, this empowers our business owners to have better control and understand every aspect of the business, and allow them to leverage instant data to boost productivity, improve processes, and drive growth. So what we mean by that, we're making faster decisions because a lot of things are more connected, so we're able to transfer data faster. Faster decisions are being made, maybe not necessarily by people, but more so by machines, like once they have the right inputs or have been configured correctly to make those decisions. And that also increases the efficiency because that allows engineers or technicians or associates to focus on things that of higher risk or higher importance that would require their attention more. So this is something I'll be getting into later in the presentation of how we would automate or start implementing some of these solutions, is starting with some of either the lower hanging fruit or where we can where technology could actually, or software could have a larger impact on what we're trying to do. But all of this is dependent on making sure we have a successful implementation of this cyber physical system. So what we mean by that is as we saw through industry 1, 2, and as the first 3 industrial revolutions, we had a lot of physical systems that were in place. The third industrial revolution led to some level of automation, but then with the fourth one, we were seeing automation and also automated decision making, which is what, as quality professionals, we have to pay the most attention to ensure that the systems are making their correct decision or configured to make the correct decision every single time. So some examples of technology that support all this. So some of that includes like a cognitive computing skills or cloud computing in order to make sure that we have access to data at all times. Mobile technologies allow us to see data in real time, not necessarily having to carry laptops or go to a dashboard or go to a computer every single time to view how the process is working. Machine to machine is what I've been talking a lot about with how we're with the cyber physical connections or interfacing, and making sure that once we have the right data there, it's actually able to send that data to the next system and make sure that systems are functioning appropriately. Through some of the other things that are listed here, Internet of Things, like we've also heard that as a buzzword with regards to how machines are all interconnected and able to communicate with each other. And what we are trying to do is make sure that that communication is intentional and also making that we're able to make the right decisions off of that. With analytics, that's all also something that will be automated and something that we would want to see or something that we would use in order to make sure that we're making the right decisions and to see if trends that we had previously observed are being handled appropriately. Like it's some type of negative trend, we've eliminated that trend or tried to reduce what's associated with that, whether it's increased scrap rates or delays. We want to be able to use the data that we've collected to show that we are making improvements. Other things that we would want to consider, how we organize our manufacturing process. So the way I think about this is if we're going through how we would organize our manufacturing floor with different Kanbans, or how we would make sure that we're meeting appropriate safety requirements, or making sure that the equipment that's necessary for certain steps of the processes are in the right order, right sequential placement, so that we're not having to walk back and forth and waste a lot of time dealing with that. And one thing we would also have to consider moving forward would be the amount of space required for making that connection. So, or making sure the machines are actually able to communicate with each other, whether it's all wireless or a wired connection. We still want to make sure that that's all accounted for. We want to make sure that we're accounting for critical quality attributes and how that actually need inspection during a manufacturing process, and how intensive that inspection would be. So that all varies based on what the risk is of inspecting or not inspecting that feature within our products. So if we're at a point where that could result in either a failing product or result in negative feedback from our stakeholders or our customers, we want to make sure that we're still able to satisfy all those requirements before passing on this product to the customer. We also not only CQAs, but we also want to be aware of our critical processing parameters, and if it's possible for us to monitor them. This is important because if we have a monitoring process in place, that allows us to collect data from that monitoring system. We can take that data and start analyzing it and put APIs or put some type of automated analysis system in place that allows us to start making decisions faster based on what we're seeing in the manufacturing process or in the manufacturing space. So one example could be like a SCADA system, where if we're monitoring our environmental conditions where the manufacturing of our products is occurring, we want to make sure that we can build in there controls. Or one easy thing is building in the controls for making sure that that the environmental controls all meet our requirements. We could also build that into our the machines to know that, so that if humidity gets to a certain point, it would either halt processing or speed up processing, or try to adjust our manufacturing process in that manner. Or we can, or another example would be, once that happens, alert the team that's on site at that time so that they can start moving product faster. We also want to be aware of how, if we're adjusting any of these CPPs or the set parameters for our process, we want to understand how that could impact our product or downstream processing steps, and if there's a way to detect what those errors are or what those potential issues are. So if there are downstream effects, that's something that we want to understand and have characterized in some manner. So that's where having some level of predictive analytics based on how the manufacturing process occurs and various robustness tests performed on that process could help give us some idea of what could occur. But then once we have that real-time data, we want to be able to reinforce this model and make sure it actually is working as intended. And the last thing we also want to consider is risk. We want to make sure that we know how putting in these automatic systems would impact downstream processing steps or impact our process if the controls were found to not be effective, or if they were down for some reason, like a power outage or something. We also want to understand what the compliance risk is associated with these new technologies. So so right now I've been working on medical devices my entire career. So that's what I have a bit of so some of the references I have in here are with regards to medical device regulations. From that standpoint, we have a lot of reporting requirements and to regulatory bodies that we need to make sure they are aware of the changes that we're making. And with certain products, they have to approve those changes before we make them. So in that case, if we had an automated process where the manufacturing process was adjusting based on input data within the process itself, we would have to make sure that we, as quality professionals working in that space, are able to understand what the intended changes are, and if all of those changes were to occur, that we have the confidence that we're still producing a conforming product. With the inclusion of all these different technologies and computerized systems, we have to be more aware of cybersecurity and how that would impact our manufacturing process. So, we see this in the news every day, where companies are being hacked every single day, and with ransomware attacks or data is being leaked. We have to make sure that we have the appropriate security controls in place to prevent that from happening, because we don't want some unknown agent to prevent us from being able to produce products or put the company at risk of having to pay one of these ransoms because of due to negligence of the cybersecurity risks associated with certain technologies. So with the implementation of these new technologies, that's something we also want to be aware of. So some of the tools that would be involved with the implementation of Quality 4.0. What I have shown on the right side is it's a high-level overview of what a company could look like having implemented Quality 4.0 practices. So working in a manufacturing space, quality impacts everything from R&D to how devices are being built, through how materials are being sourced by procurement, all the way through sales, logistics, and if we have to deal with servicing, that's also impacted by, or that's something we have to take into account from a quality standpoint. The way that with the advancement of technology, with more quality tools being available to us, what we're seeing is that more data is being generated, and we can make more decisions based on having more information. So that's one thing that's very important as we collect data and as we put in these new technologies, is that we have some level of centralized quality data management, and are able to show the rest of the company how that data is impacting our products or our process, or how it's how it's being used. We also, from a product development side, there's more of an emphasis on following agile methods. So building testable prototypes and retesting those, and essentially trying to work in parallel as much as possible, but in order to build a finished product where you're like moving your validation testing more upstream during the development cycle. That's what is one thing that would help with getting new products out to customers. Having dashboards everywhere to see what the performance are, that's also something that's very useful. We want to see not only just previous performance or daily performance, but we want to see real-time performance too, of how equipment or how systems are working and detecting issues or collecting data, and also be able to see what the real-time decisions are. So that allows us to, that's one way of showing that, making sure that we're reviewing the decisions being made and making sure that they're still, the control itself is still effective. So we've talked about predictive analytics already, making sure that our models are accurate, and as long as we are collecting more and more data, we can build better models based off of more robust data, and then adjust the model accordingly to make sure that they're making the right decisions. And then digital SOPs are something that we've talked about, or that's a kind of a new concept, since we are used to seeing SOPs written down and as something something that's written down on paper. One option to moving forward would be like actually taking video recordings of what we could be doing and use that in lieu of the SOP, since we have the technology there. We still have to have something written down to make sure we're meeting all of our compliance requirements. But then that's still an additional tool that would help us with training or making sure that we're doing the same thing the same way every single time. And then the last thing too is transparency, because what we want to show is that we want to make sure that people understand how these systems are working and how they are interfacing with each other, in order to make sure that we can make sure that people understand what happens if there were problems to arise within the manufacturing space, or if there were, and to make sure that they are aware of what problems they should be looking for. And also we want to also make sure that people understand why the systems are important, and also that allows more people to, by allowing more people to see what is going on there, that allows more ideas to come up with how we can also improve things. So that's something that we all want as quality professionals, to make sure that we are constantly improving our process and not just sticking with the status quo, but like making sure that we're moving towards making our processes more efficient and less error prone. That leads to the question of, how do we trust the data that's collected, or trust the decisions that are being made? So, I mean, Gilbert's right. Like, there may be situations where we've had the incorrect data for the longest time, but then we might not have known until we had just asked. So once we've asked the question, now we have to do something about it. So I'm going to start talking about data integrity now. Were there any questions about Industry 4.0 or Quality 4.0 before I start this part? Sorry. Okay, I will move on then. Okay, so now I'm going to be talking about data integrity. So Industry 4.0 relies on automation of decision making, and based on how we automate data capture or data entry and how we configure the system to process data that's being collected. So that requires us to have controls over how we enter data, how we capture data, how we process data, and also how we use that data. But then, so that's where we see that we need controls over how data is being processed in real time. After we've actually made those decisions, we still want to go back and understand how we made those decisions and make sure, in order to review that the system is working as intended and show that it's the controls are effective. So this is mainly important during audits, or if we're going through manufacturing or management reviews. We want to make sure that we have data that's available in order to recreate previous situations or recreate how decisions were handled, or how situations were handled and decisions were made. So that requires us to have controls over how data is backed up and how it's archived in order for us to go back and recreate those situations. So a couple definitions first. What we mean by data is facts or figures or statistics that are collected for reference or analysis. And the reason we want that is to allow us to reconstruct events. So in the medical device field, and this also applies for pharmaceuticals as well. All original records and true copies of original data of records, including source data and metadata, and transformations of that data that's generated or recorded at the time of that GXP activity. All of that is required in order to allow for full and complete reconstruction of that activity that's being reviewed. So what I mean by that, the example that I'm going to bring up is if we made, so in regulated industries, we go through audits every so often. And when we pull up and auditors may ask for any record within the retention period. So if they ask for a record from 2 years ago, we want to be able to present them the record that shows that the product was built as intended, as we intended it to be built 2 years ago, and all the supporting data to show that all of our systems and all of our test equipment, all of that was working as intended at that time. If there were issues, we want to show them that we handled those issues correctly and that we have the objective evidence to show that we resolved what issues had occurred. So that leads to a lot of information that needs to be collected and a lot of that needs to be managed at that time. So that's why in the past it was always file cabinets upon file cabinets upon file cabinets of records or information that was being stored in by QA personnel. With technology nowadays, we can store a lot of that information digitally, but that means we also have to have the controls in place to make sure that when that data is being stored digitally, we have the assurance that that data is not being adulterated or altered either intentionally or unintentionally. So that requires us to put controls in place to make sure that data is not being changed, or make sure that we have backups in place if there are issues with the original version of that data. And we want to make sure that we do this with every piece of data that's required in order to reconstruct the events of what we're storing this data for. So what we mean by data integrity is the degree to which data are complete, consistent, accurate, trustworthy, reliable, and evidence to show that those characteristics are maintained throughout the entire life cycle of that data. So this applies to all types of data processes, so electronic data, paper or physical data, and hybrids of either electronic or physical data. Data integrity will apply to all of those different types of systems. And how we actually show that we meet all those requirements is the acronym that we use nowadays is Alcoa Plus. So before I get to that, one thing that to draw a distinction between is data quality and data integrity. So data quality requirements, the easiest way to think about this is with regards to an inspection system. When you're inspecting for a particular attribute, the first thing you want to understand is, are you measuring something, or is this is this a variable inspection, or is it an attribute inspection? So if it's variable, you have some type of measurement there. At that point, if you're measuring a length of something, is it okay to use a ruler, or do you have to have something more precise where you need a caliper, or do you need some type of computerized system where you can get even more precision there? With each of those different options, they all come with different costs that are associated with that. And that's where the balance comes in of like understanding what we actually need to measure versus what we can use to measure that specific feature. So data quality requirements are, in that instance, would be making sure you understand what precision is required, or essentially that your data is fit for purpose and that your data is objective. Essentially that you're actually able to draw the conclusions that you're saying are there. Usually those requirements are established by the test method or what study is going on, the data analysis, what type of inspection method is happening, or a one-time event. So those are all, that's how you define your data quality requirements. What we mean by data integrity is, did we actually collect the data that was intended? So if we had, going back to the length measurement example, if we were using a ruler, did we actually use the correct ruler? Like, did we use the inches side? Did we use the centimeter side? Like, what's the specification provided for that? Were there, or if we were using a computerized system where it was actually, is it automatically capturing that data? Is it storing it appropriately? Can we pull that data back? If there was any type of data processing occurring, was it done correctly? So is that a manual calculation that the inspector is doing? If it's automated, was the automation set up correctly or configured correctly? We want to make sure that the data is not manipulated so that when we go back to it, go back to that record, we can actually view what how that decision was made at that time. And we want to be able to show that the intent of that data does not change over time, so that when we look at that record from yesterday or from 2 years ago, we understand what's actually going on there. So the requirements with regards to data integrity are defined by the system itself and applied over the lifetime of how long that data is being retained for, not necessarily just a one-time event when that data is being collected. So the way I like to think about it is that the data, if we're talking about the study for any type of study that's going on, the study owner is going to decide what the data quality requirements are, like with regards to what type of data analysis that they want to do, and make sure that all that is documented appropriately. From a data integrity standpoint, we want to make sure that that's actually preserved. So we have original copies of that protocol, original copies of the data sheets where things were recorded or printed out, and original copies of the report and the data analysis and approvals that were given at that time to make sure that we've actually satisfied all of our requirements. So going back to Alcoa, on the previous slide, there are a couple terms that were bolded. That is the acronym for Alcoa, based on just the definitions for data and data integrity. So data integrity requirements, they mean that if our data is accurate, that's legible, collected contemporaneously, and we're dealing with the original data and it's attributable to a specific event, or that's how we know we've met our data integrity requirements. There are additional requirements too associated with that, showing that we are able to completely reconstruct the events of how they occurred in that specific event. When we mean that they're consistent, it means that we have everything is sequential and we're actually able to go through and review it at the same way every single time. So if we're talking about data being entered into a database, we want to make sure that data is being entered into the correct data is being entered into the intended fields every single time. Or the equivalent for a paper form would be, we have a paper form and the correct data is being entered in the listed fields as intended. When we're talking about data being enduring and available, we are referring to records or making sure that we have appropriate record control or record retention policies so that whenever a review or an inspection is occurring, we can obtain those records as needed, and that access to those records is limited to those that actually need to have access to it. So that's also how we prevent changes from being made to specific records, and also ensure that we know who, ensuring that only a handful of people can actually do, or knowing if things were to go wrong, how we can actually go through and investigate why it went wrong. So that's where having appropriate access controls are important, because what we would want to see in order to meet like transparency requirements for quality 4.0 is that the data is available, but then what may not be available is the raw data that people can, or the raw data, or form of the data where people can actually go through and make changes to it. So it could be as simple as making data read only on a Excel spreadsheet, or more complicated where you have to log in to actually view data. So from medical device and pharma standpoint, a lot of these requirements have been around for since the early 2000s, when Part 11 was, or 21 CFR Part 11 was implemented. So these regulations come from there, as well as 21 CFR Part 211, which is the GMP requirements for pharma. Recently there have been a lot of guidance documents being released by a lot of regulatory and industry groups that want to try and summarize what all these data integrity requirements are, because they are there are various different guidance documents from all around the world, or different regulations that come out frequently. It's hard to keep track of a lot of that. So with newer guidance documents coming out, it helps with keeping them all in central locations, and allows us for a quicker review. So the diagram on the right shows us which aspects of Part 11 are still being met with data integrity requirements that were previously, with the definitions that were listed, or with the requirements that were on the previous slide. So the first part of the definition for data integrity is that it applies to all types of data processes. So I mentioned before that there are electronic data processes, physical data processes, and hybrid data processes. So electronic data processes are, it's a very simple definition of like how electronic data is generated by electronic systems and handled electronically throughout the entire life cycle. Physical data, data is generated physically and handled physically. So that can mean handwritten signatures on physical forms, and then it's stored in a file folder in a drawer in the document control room. Hybrid data processes, that's usually what a lot of companies actually use right now. Your hybrid, that's where it may be data, you have aspects of both electronic data processes and physical data processes all present within one data process. And what I mean by a data process is starting from when data is entered into a system all the way through its archival or destruction is how it's handled. So when it's hybrid, there are aspects of that could be physically handled or electronically handled. So what I mean by that, you could have data that's electronically generated, but then printed out and signed off by hand. Or you could have data that's written down and then scanned into a system and then signed electronically. Those are examples of hybrid systems. So physical systems, examples of those would just be your paper forms that are used for signing off on changes, or making on equipment tags or test requests. Chart recorders are also generating physical data based off of a physical measurement. Electronic data, or examples of electronic data processes would include integrated lab equipment with your LIMS, or electronic document management systems, manufacturing execution systems, anything like that, where you already have some level of software automation present to help either keep track of product, or keep track of equipment, or keep track of data. All that is still generating data, and it's all things that we want to be able to know where, have appropriate controls over to make sure things are working as intended. And when I say maintain through the entire life cycle, this is what I was mentioning before with regards to what a data process looks like. So we start with our data generation through and recording of that data. So if we were talking the chart recorder example, your data generation event could be heating up an incubator. What you're recording there is the temperature at that specific location where that thermocouple is present, how that data is being processed. So in the case of your chart recorder adjusts like where the pen is based on what the temperature is being measured. So how that physically is occurring, and then what's being recorded onto the chart recorder is what is occurring here. If this was an electronic system, what we would be tracking is how that physical measurement is transformed into an electronic measurement and then stored in the specific database, as we see at the end of this process. If there was any type of transformation that was occurring with that data once it's measured. So in the case of this chart recorder, we're going from a temperature to your electrical, some type of or the thermal, so your thermal event to adjust how the thermocouple is working, and then transfer of that. So it goes from temperature being measured in one area, adjustment of your thermocouple, and then being recorded on your chart recorder. Once you actually get the chart pulled off of there, then you can use that data for making your decisions. And then you store that record based off of what is actually happening, or in order to show that you've made that decision. And if you have to transfer it or retrieve it for whatever reason, you've done that. So what we're, from a quality 4.0 standpoint, industry 4.0 standpoint, we want to try and automate as much of this as possible. So for an electronic system, we can already go through and do that, where you automate how data is being recorded, how it's being processed, and how it's being used. What we also want to make sure of is when it's being used, we have some level of assurance that the system is making the appropriate decision based on what is being measured. So going back to the incubator example, if the system is, if you store samples in that incubator and it suddenly goes out of specification, either it goes too high or too low, there may be situations where you link that to a timer that allows the technicians to understand what the how long the samples need to stay in that incubator. If the temperature adjusts in one way or another, you may be able to adjust how much time is required for that incubation period. It's easy for us to say that you just keep extending it more and more, but there are some efficiency gains that could occur if we decide to try and automate it that way. But then that goes back to making sure we understand how that data is being used, and we have assurance on how that the data is being used appropriately or as intended. And then once we've made that decision, or once the system has made that decision, is recorded, that data is then recorded, and that decision is also recorded, and we are able to understand how it's being recorded and transferred if necessary. And so, and just through that example, we can see that we have to make sure that we have data integrity controls over the entire life cycle for any type of data. So, I mean, with the chart recorder, we saw that it was, once we generated that paper record, we still had to make sure that it was being stored appropriately so that we could pull that up if we need to go back and review that data. With the electronic system, we have to go back and we have to make sure we have that data stored so that we have assurance that the system is working correctly, and also if we have to go back and review it for either audit purposes or inspection purposes. Based off of that, that's why the controls that can be put in place all vary based on the type of data process or the intent of the system. So if we are at a place where we don't need that level of automation, it doesn't make sense to go and automate something if it's not required. But if there is an actual use for automating that system or automating that process, and there are actual gains that can occur that can help improve the business process, then we want to start exploring options for trying to go and do that. So I have here a comparison of like when it's okay to use a physical system or when it's okay, or the pros and cons of using a physical system versus an electronic system. Because what we see often is that all the requirements that are established for an electronic system may make companies think that it's better just to keep everything on paper. But then what we actually see is that there's a lot of requirements all up front to make sure that the system is configured correctly and that everything is working as intended. But then there's a lot more pros that we see at the end with regards to a functioning database. So I won't go through all these, but you can see here, like with regards to where the cons are for the electronic system, they're mostly all with regards to development and validation of that system and implementation of that system. There are some, and there's also some with regards to data transfer and migration and destruction of that data. But with regards to a data process, managing the physical data itself over time does add more cost, add more time, and actually take up a lot more space than putting in an electronic system. So with regards to data integrity and quality 4.0, Quality 4.0 requires a lot of automation of data processes and automation of decision-making processes to make sure that we are able to focus on things that actually require our attention and put more trust in that the system is working as intended, and also that that allows us to make better decisions based on predictive analytics that are occurring on the side. So some of the features that are the tools that we would want to consider having in place in order to effectively implement Quality 4.0 systems would be making sure we have appropriate audit trails or appropriately configured audit trails and conduct audit trail reviews. So what I mean by an audit trail is something that keeps track of essentially how a system functions. So most systems will have a system log in there, but we also want to make sure that we know how to read that system log. We also want to make sure that there's no way that we have appropriate controls over that system log so that no one can go in and like remove entries from there, and so we want to make sure there's appropriate security over that, and that the information that is being captured is what we want to be captured. So it could be as simple as making sure, or as a timestamp, with a timestamp, you know who was logged in, what change they made, and then yeah, as simple as that. There are more complicated ones that have approvals in order to make changes to a system, but as long as we have those requirements established, we want to make sure that the audit trail is functioning as intended, which also aids in investigations for that system if things were not functioning as intended, or if we run into situations where we're producing if our scrap rates go up. Another tool that's useful are electronic signatures for these systems. So there's a high level of automation that's required for a lot of these Quality 4.0 systems, but we still want, for critical steps within the process, we may still want to implement electronic signatures to sign off on something before proceeding. That allows us to, putting those gates in the process, it allows us to make sure that if we need to, we can go back and review the previous process if necessary, and make sure that if we need, that the appropriate people have taken a look at that, at everything that has been collected up until that point before moving forward. It also allows us, if we need to go through and test products, we can sign off on things electronically and not necessarily have to keep track of paper records. So that's a huge advantage there. I'm also biased where I prefer a computerized system over all of that, but I think also with COVID, that's also shown the advantages of having those computerized systems there, so that if we're in situations where we are now, where where a majority of people may be forced to work from home, we can still make sure that a lot of the manufacturing process where the system is working as intended from without having to go and physically be on the floor at that time. Other tools that are important are databases and data management software. So this is where a lot of the data capture and data migration and backup and archival controls are important. So that goes back to how make sure we have requirements set up for what data needs to be captured, how it's being transformed, how and what data needs to be captured, like metadata associated with that. So date and timestamps are usually collected, where the data is coming from, maybe IP addresses for the ID of the system that's generating that data. These are all examples for things where we want to make sure that we have a traceability to where the data is coming from, and that we have that traceability and we can reconstruct events if necessary. With regards to data processing software, what we want from a DI standpoint, we want to make sure that what level of automation is put into that software is validated to a high degree of assurance to make sure that the software is doing what it's intended to. So it could be as simple as a lab testing software where you enter the data in there and it's pulling data from the right locations in order to perform the correct calculations, whether it's like creating a standard curve or custom-made calculations. Like once we have set all that up, we want to make sure that that is all working as intended. So usually that involves like some level of positive testing and negative testing of the system itself. So we have a data set that would create errors, and that all the errors are generated as intended. We're actually able to get a appropriate response from the system like that, and we're able to transform data as intended. One thing that's very important with all of this stuff is understanding how systems interface with each other. So that's very important as we establish how different manufacturing equipment all communicate with each other. We want to make sure that the data being output from one machine is in a format that can be read by a second machine, and that once it's in that correct format, it's actually able to make the correct decision. So, an easy example is like if we had someone speaking in French to someone who only understands Hindi, there's a language barrier there. We want to make sure there's some level of translation that's going on so that they actually understand each other and are able to make the appropriate decision. It's a very extreme example using people, but then from a machine standpoint, we want to make sure that the outputs from one machine can be read and decisions can be made as inputs to the next machine. So that's what we look at with regards to input-output testing. We also want to verify the authenticity of the systems and make sure that they're actually communicating to the correct systems, because we don't want to be in a situation where you could spoof an IP address and send data to send incorrect data to a particular system and cause the process to function incorrectly. So that's where having some level of authenticity to make sure that system A is actually talking to system B, so that it's actually working as intended. And then the last thing to also consider is making sure we have data integrity reviews that are actually going on. What we want to look at during a data integrity review is we want to make sure that the systems, the controls that we have with regards to data integrity are all functioning as intended. So usually we'll have metrics in place that say that I keep track of how well that system's functioning or how well that system's being used, whether it's users, whether it's keeping track of like how often users may make a mistake with that system, or every time the system crashes for whatever reason. Like this allows us to, just having that information allows us to go back and make improvements to that system moving forward. That also requires us to establish what those DI requirements are. So we may have a system that's not capable of storing data, but then, for example, you may have a system where it only stores data on flash memory, but then it's also able to create a physical printout. So at that point, you're creating a physical printout of that data. Now we have to understand how we're using that physical data that's being generated. If there are ways to take that data from that flash memory and then put that onto a different system, we want to explore those options because that's less manipulation of the data, or less transformation of that data from an electronic to a physical state, which increases additional risks associated with that process. And we also want to have some level of change control in place. And that's something that we would want to look at through our data integrity reviews. So if there are changes to that system, we want to understand what the impact is to everything else. Because if everything is already integrated, we want to make sure that one change to one machine does not cause all the data that's being transferred between the different pieces of equipment or different machines or different systems to essentially fall apart. So that's why we want to make sure we have appropriate change controls in place, or change control or change reviews to make sure that that's all working as intended. I do have the references here with regards to medical device and pharma regulations for these two, if people are interested. So the last part I'm going to be talking about today is how we actually go through implementing Quality 4.0. So this is from a survey ASQ did a couple of years ago. What they've seen right now is that right now most companies within, well, US and primarily Germany have not actually put a plan in place or have it and made a decision on whether or not they would start implementing Quality 4.0 tools, even though most companies right now see that Quality 4.0 or Industry 4.0 is going to have a huge impact on their industries within the next 5 years. So there's a small portion of these companies that are actually in the planning or implementation phases of this. No one's actually done with this yet, but then what we can see too is that most of what we see, or most of the front runners that we see for actually implementing Quality 4.0 are in Europe compared to in the United States. So that leads to the question of like, why is there this lag? Like, why have we not started adopting those technologies? The biggest reason that ASQ was able to find was it mainly has to do with talent acquisition, and then digital strategy just being unclear or lack thereof. So that's where it becomes important to like build the skills up for understanding what data integrity is, or build the skills up for how we would actually go through and configure some of these systems or create some of these systems. Like there's going to be a lot of automation that is involved with this, so that involves a lot of machine learning skills and making sure that we know how these systems are actually able to interface with each other. There's also a lot of data processing and a lot of understanding how those data processing and building the models associated with this becomes important too. Because what we want to show is that once we're actually able to build intelligent models based on the data that's being collected. So other reasons that people say they haven't started adopting is lack of a quality culture. So that varies based on the industries that people are working in. So they're like working in a regulated industry, like we have to meet quality management requirements. So we have some level of a quality culture in place. But then there are industries where that's not required. So at that point, there's no reason to actually go through and try and implement, or the business may not see Quality 4.0 as an advantage just yet. But there are advantages of having the live data collection and also decisions being made in real time. Having outdated systems or infrastructures, that's always a problem that we're going to be running into, because what's required for a lot of Quality 4.0 initiatives is going through and upgrading a lot of that space. And what we may have seen, what I alluded to before is that COVID may have accelerated some of those decisions because of forcing people to be remote. There may be situations in the future where we are remote for other reasons that don't involve global pandemics. But if we're remote in those situations, we still want to make sure that we're able to produce products in a safe manner. And then the last issue I want to highlight on here was the cybersecurity concerns. So, I mean, we see this more and more every day with more and more cybersecurity attacks or ransomware attacks that are occurring. So that is a big hurdle, but that's also something that a lot of IT professionals right now are focusing on and trying to improve that layer of defense to make sure that systems are working as intended. So how ASQ proposes going through and implementing a Quality 4.0 system, you want to first start by prioritizing where the pain points are in the existing manufacturing process. So once you identify what those pain points are, we can start looking at possible digital solutions for those pain points. So if we have some part of the manufacturing process that's performed very manually, or even an automated process where there's a high scrap rate because of the operator's attention is divided between that and a different system. It may help to try and put some level of automation in there, or look at some digital solutions with regards to how we actually automate that part of the process. It could also be as simple as looking at electronic document management systems. Once we go through that once we go through and implement that, that allows us to reduce how many things that an operator needs to keep track of in front of them. They may go from having multiple, like a batch record and multiple records in front of them, to just one computer or one tablet in front of them with all the information on it. Once we've identified what those pain points are, we want to identify, test, and scale up use cases. So that's what was referred to with the agile product development, where we identify what the solutions are and start testing what the best option is. And then once we've gotten to our best option, we're validating along the way and showing that the solution actually meets all those requirements. So that's where we've gone from identifying what the opportunities are. Once we've done that, that's like very much a system or a process level. When we start looking at a larger company or trying to fit Quality 4.0 goals into how the larger company works, we want to start defining roadmaps and what the vision is for the entire company. So if we can show test cases or use cases where we were able to automate or able to implement electronic or computerized solutions for systems that we had lots of issues for, and we're actually able to show that it's reduced downtime, the scrap, like all of the different forms of waste associated with the previous system, we can use that as our test case, as a reason for trying to go through and improve other systems within the company. So that's where we prioritize opportunities and build more business cases for why the automation makes sense. After we've shown that it works for a handful of systems, we can show the cost savings there too. Cost savings are it's the easiest way to make that argument to management, saying that we're able to save costs with regards to reduced scrap rate or reduced downtime. And from there, it propagates throughout to make sure that we're actually able to, that shows the benefits of implementing systems like this. While we're doing that, we also want to make sure that the staff has the required skills, because a lot of these systems and a lot of these systems and processes and tools do require a greater knowledge of statistics or a greater knowledge of how computers work or IT in general. So we want to make sure that the staff that's there are able to build those skills up and also able to handle problems because as they arise, rather than waiting for just one person to come back and address all those issues. And then the last two things are, so as we go through that, we are scaling up and realizing our quick wins, and then we continue that as we move through the entire company. So that's the basic overview of the plan that's proposed for how we would go through and actually implement Quality 4.0 culture within a company. So in summary, as quality professionals, we need to make sure we have these additional tools in place in order to keep up with the advancements of technology, to allow for faster decision making and allow us to build product and keep up with demand as we put more and more advanced technologies within our manufacturing space. So those additional tools do require us to automate some or create some level of automation for decision making, but we also have to be able to trust those systems to make the right decision. So that's where we have to make sure we have the appropriate data integrity controls in place to make sure those decisions are trustworthy and make sure that they're trustworthy. And understanding what decisions need to be made will allow us as quality professionals to focus on our efforts on implementing Quality 4.0 within our individual companies. All right. I'll take any questions now if you guys have any.
Any questions? Feel free to unmute yourself. Dr. Lau, is this something that Purdue is looking into for control of its systems and any data across the organization?
Yeah, I say so. I mean, in the curricula, we focus on data quality and cybersecurity issues, data management. Some of it's treated as a process, but a lot of it you'll find in a variety of the curricula, especially in the IT spaces. Increasingly, though, in the engineering technology spaces too. So, yeah. And obviously, there's lots of work being done on both Industry 4.0 and Quality 4.0 research-wise, within the institution. Nicely done, Kiran.
Thank you. Yeah, like it was interesting, like going through all this. Like, I'm also trying to think of ways how we would try to implement this like much easier in regulated industries, just because I mean, from the so Jared and I, we work in the medical device industry, so trying to understand how we can balance our compliance requirements with like this level of automation in order to scale things up. It's something that I think about a lot.
Yeah, and some of what you discussed is tied to the industry you're in with data integrity requirements and electronic record keeping. So not all sectors have those same sort of regulations in place.
Right. Yeah, that's something that we were focusing on for the past couple of years, just making sure that we have appropriate data integrity controls in place.
Mm-hmm.
So that's something that the industry is focused on, or the FDA has also been focusing on that a lot recently too.
Sure.
I had a slide on that previously where you could see the exponential increase in the number of warning letters associated with data integrity controls.
Yeah, remind me again, how many FDA warning letters? What's the percentage of increase that's gone out?
I can pull that up real quick.
I think it's double-digit growth in those.
Yeah, it was massive. I remember. Yeah, so the numbers I was looking at was before COVID. So yeah, so I can share this real quick.
Yeah, maybe explain what an FDA warning letter means again.
Yeah, sure, I can do that. So, uh, so for pharmaceutical companies and for medical device companies, and also for just biologics as well, if we have to show the FDA that we're meeting their requirements from a quality standpoint and also from a product safety standpoint. If we are deficient in any way with regards to what we're showing that we're not meeting any of the FDA requirements or regulations or industry regulations or somehow adulterating our product, then we are issued warning letters, which is the FDA's way of saying that we have to go through identifying what our issues are all publicly. And once those are issued, usually, or we have to go through and address all those issues before we can actually go through and release new products onto the market. So also with those warning letters too, like if publicly traded companies are issued warning letters, usually you see a drop in their stock value, usually by 10 or 20%, until they've actually addressed what until they've actually closed what that warning letter was. Just because what the FDA is saying, essentially saying in that place, is that this product or this company is producing products that are adulterated and could potentially pose a public safety risk. Yeah. So that's also sometimes associated with recalls, but then depends on what level of recall that we're looking at.
Right. Yeah, thank you. Yeah, so to answer the question then earlier, like in the next few weeks, we'll be going through like the whole data collection cycle, and we'll start with basically mining for data, using raw data and a few case studies, dealing with some municipal government functions here. So yeah, we will. We'll do, well, we call it, really engineering, we call it data collection, but it's, I think, the more up-to-date term is data wrangling.
Okay.
Yep.
Yeah, I've heard data, I've heard
there you go.
Data
There's
generation. yeah, I was looking at the slide.
Yeah.
So this is what we were seeing with regards to number of warning letters. So starting in 2008, it was less than 10, but then up in 2017, we were at 60.
That's a career right there.
Yeah. Since this only went up to 2017, I went through and did some of my own digging to see how many more were issued after that. We had 45 more issued from 2018 to the beginning of 2020. Wow. With regards to data integrity, but then 45 out of 250 that were issued from those relevant FDA offices. Yeah. And they always reference regulations with regards to how we manage laboratory records or production batch records. Yeah. Sure. How investigations are recorded and data generation controls. So that's
There's some new information you got in here. It was really good.
Yeah, thank you.
I'd say, with Quality 4.0 too, we're like on that technology S-curve. We're in the hype phase with it. I saw this the other day. I think 5% of companies are actually implementing it. So there's a lot of talk. What is it? What is it not? So there's quite a bit of work to be done, but heading in the right direction.
I know that. So there was an article by ASQ that they had done with BCG that was showing that so many companies haven't even started talking about it. I think they said like 63% hadn't actually started doing anything yet. So there's a lot that still needs to be done.
Yeah, that's okay.
Yeah,
that's a good thing.
Yeah. Are there any other questions or things people want to discuss now?
I just had a question about the companies in Germany that are implementing it. Okay. Are they mainly heavily regulated companies that are at the forefront there?
Or? I haven't actually gone into or researched like which companies specifically in Germany were within the scope of that survey, but I can look up that information and get it to you.
Okay. Yeah. No, that's fine.
Okay. Yeah, I know. So the Now, like my thought is that depending on what type of in the EU, they have like different regulations than we do here in the United States. So depending on which industry is, there may be more or less regulations associated with it. So that's where it may vary, like what people have to do from a reporting standpoint.
Yeah, and probably as far as like cybersecurity increasing will probably increase across all industries for quality 4.0.
Oh yeah, definitely.
Thanks.
Okay. Are there any other questions or comments?
I just want to say great presentation, Kiran, and greatly appreciate it. Yeah, it'll be interesting to see how not only we implement, but other businesses within the industry and other parallel industries implement both DI and Quality 4.0. So.
Okay. All right. Yeah. Thanks, everyone. Jared, I can send you a copy of these slides if you want to send that out to everyone.
Yeah, that'll be great. We'll have the recording, and then yeah, it'll be good to attach the slide deck as well. So I greatly appreciate that, Kiran.
Okay.
Yeah, I was going to ask about the recording. Where will it be posted again?
It's been both on our ASQ actual site, and then I think we've been actually uploading it to YouTube as well.
Oh, that's right. We do have a channel. Okay, super. Because I'd had inquiries about that. So
Yeah,
I can remember.
and I'll follow up with Tom. I think he got the last couple ones up on there.
Yep,
And we'll make
sure.
sure that gets shared out as part of our next newsletter as well.
Super. Yeah, great presentation and attendance tonight. So
Yeah. Thanks, everyone.
appreciate it.
Thank you all, and look forward to joining for our October meeting.
Thanks much. Take care, everybody.
Thank you. You too.
Yeah.
Bye-bye.